All right. So given this example, it states a Norman window has the shape of a rectangle surmounted by a semicircle of a diameter equal to the width of the rectangle. See the figure. See my little beautiful drawing. If the perimeter of the window is 60 feet, what dimensions would emit the most light? So we need to maximize our area. So this is the shape that we're given, right? And we know the diameter equals the width. We know that the perimeter is 60 feet. Okay, so, and we need to maximize the area. So, so what do we need to do? First, we need to find our, we first need to find the perimeter equation. So we need the equation that represents the perimeter, okay? Once we have found the equation that represents the perimeter, we are going to find the equation that represents the area, okay? Once we have that, we are able to find the vertex, and our answer is the x value of the vertex, because that will tell us the maxima, so that will be able to tell us the y. We're trying to find what will give us the most light. So what is the x value that will project them, that will allow the most light? So what is the x value that will give us the y? So we need to find the equation that represents the perimeter. From there, we need to find the equation that represents the area. Once we have that function, we're able to find the vertex. And our answer is the x value of the vertex. Okay. So we are going to think about this. That is, I cannot do a straight line. Cannot do a straight line. So this is the image that comes with our example. This is my shape of a window. Okay. The problem tells us the diameter of the semicircle equals the width. Okay. We have x and y. For the diameter, we are going to use the letter x. So for the diameter, we're going to say that equals to x. Okay. For the length, we are going to say that is y. Okay, so this is going to be my y. All right. If you notice, I have some things here right now that we are going to do, we're going to need as we go forward. All right. So the circumference of a circle. So for circles, we don't use perimeter, we use circumference. So that's what goes around it, right? For the circumference of an entire circle is 2 pi r. Now we are working with the semicircle, so that is pi r, okay? Now we are given the diameter, we are not given the radius, okay? So we will need to change, use different circle. So the semicircle, instead of saying radius, we are going to substitute what is radius? Pi, the diameter divided by 2. So that there. When we get to the point where we're going to use area, because we're not there yet, it's going to be 1/2 pi d squared, d over 2 squared. Now, what did we said that the diameter is? X. So this will change to pi x over 2. Oh, I need to move my head. Yes, I need to move my head. Let me move my head. Let's put it right here. Oh, okay. There. So then this one over here, I have it simplified somewhere. This simplified will be 1/8 pi x squared. Okay, this, we don't need that one right now. Okay, we're gonna work with the semicircle. Now, the perimeter, okay, so remember the perimeter of any shape is simply the addition of all the sizes. Okay, so for the perimeter, okay, we are going to add, how can I put it? We are going to, no, we're going to add this size plus this size plus this size plus this size. Now, no, remember this and these two are equal to one another, so the same value there, okay? And then this, okay? All right. I'm gonna take that out because I don't want to see that, because I want to make sure you can see. Okay, so I have it right here to make sure I don't make it a mistake. So this side, so is y, right? And this one is y. So we are going to do is 2 times the y plus, okay, I have my width right here, okay, so this is going to be my x plus whatever the semicircle is. Now, remember, this is the diameter of the semicircle. I cannot add this distance for the rectangle and the semicircle because they're both the same. So whatever this is, I'm going to add it here. Well, I know what the circumference is. The circumference is pi x over 2, right? Yes. Now, the problem tells me the perimeter is 60. So I can rewrite that as 60 equals 2y plus x plus pi x over 2. Okay. So now we have the equation that will represents my perimeter. Okay. Now, I am going to solve for y. All right. Given this, I am going to solve for y. Now I'm going to rewrite it in another page right here. So I have, let me see, make sure I have the one that have not solved. Make sure I write it correctly. I wonder if I can copy. No, let me not play. 60 equals 2y plus dx plus, why am I whispering? I don't know. Okay, so when I move everything to the left, right, I'm left with 2y. And then I divide everything by 2. I can multiply by 1/2 or divide everything by 2. But when I do all of that, divide everything by 2, all of this, whoop, by 2. I'm going to write the y on the left, but again, it's the same. You are going to simplify that, and that's going to give you 30 minus 1/2 minus 1/4 pi x. I have forgotten an x right here. Okay, so this, let's not get stressed about it. So this is, let me pointing. So this is saying negative 1/2 divided by 2 over 1. Flip that. So it's negative 1/2 times 1 over 2, negative 1/4. Let's not forget that, okay? That's where the from 1/4 come from. Okay, so now we have the linear equation that represents for the perimeter in terms of y, in terms of x and y. Okay. From here, we need to now find the area. Okay, so what do we know? We know that the area, let me see if I have that here. we know that the area is 1/8. I have it wrote somewhere here. Oh, I wonder, yes. Yes, so we know, let me write that down. So the area of the let's use different colors because it's like too plain. Yeah. We know that the area of the semicircle is 1/8 pi x squared. Okay, and that comes from this right here. All right, from the actual formula of the area of a circle to then take it to the area of a semicircle in terms of diameter. All right. Okay. And then we know that, and this is the area of the semicircle, right? And then this is the area of the rectangle, which is the length times the width, but we are using, what did I say the width was? Y. Yeah. So we're using Y and X, okay? Those are the variables that we're using. Okay, so we need to find the total area. So that is simply the length times the width plus the semicircle area, okay? So this is the square, or maybe I should just write it like that. I should write it like that for you. The rectangle, rectangle plus the semicircle, okay? So now let's put all of that together. I feel like you should go to another page. Let's go to another page. And I feel like this is too, it's not thick enough. Let's use thicker, a little bit thicker. Okay, so when I have my total area, let me write that down, total area. So the total area of the rectangle, we have x times y, plus the total area of the semicircle, we have 1/8 pi x squared. Now, notice how I don't know the total area. I don't know the value of x, and I don't know the value of y. That is too many unknowns. But I do know what y is because we have that right here. Y is this right here. So I'm going to substitute that. So my total area, I know what y is. Y is 30 minus 1/2 x minus 1/4 pi x, close parentheses, plus 1/8 pi x squared. Let's go ahead and distribute the x. So we have 30x minus 1/2 x squared minus 1/4 pi x squared plus 1/8 pi x squared. Okay. We have, wait a minute, I feel like I skipped something. Oh, no, right here. I totally forgot about the 30. You see how this is x squared, x squared, x squared? They are all like terms, all right? They are literally all like terms, and we can combine them together. Now, I do know that we have pi. As of right now, we have it in terms of pi, but we don't need to keep it like that, okay? When you combine this term with this term and this term, you're going to get not a beautiful fraction. It's not going to be a beautiful fraction, but that is okay. That is okay. Your fraction is going to look something like this, okay? Minus 357 over 400 x squared. And what I did for pi, I rounded to 3.14, okay? Now, if I'm gonna write this in descending order, and this is my total area in terms of A of X, so 8 of X, okay? I'm gonna write it in descending order. That way it's easier for us to look up the A and the B when we are finding the vertex, all right? So A is negative 357 over 400, and B is 30. C is 0. We don't need it, but just in case. Okay, I need to add another slide because we have run out of space. Oh, I went in the wrong space. Come on. Oh no. Delete. Oh, and my face is not there anymore. My face is not going to show, but it's okay. Okay, now we're going to do the vertex formula, okay? So the vertex is x equals negative b over 2a. Well, negative b is 30. Is 30 negative? No. Over, what is a? 2 times negative 357 over 400. When you put that in your calculator, you're going to get 16.8. That was a long problem, and that is our answer. So let's get back to it. So in this problem, we have our scenario. That scenario, the application gives you the image. When we set it into our x and y coordinate plane, okay, for the did I wrote that down somewhere? For the diameter, which both the diameter and the width, we're using x. For the length, we're using y. All of this, the circle. So the formula for the circumference of a circle for the area, to know what the diameter and the radius mean. All those things are from previous knowledge, all right? So first thing we did, we constructed the perimeter linear equation. From that, we found our individual area for the semicircle and for the rectangle. Then from that, we went to the total area together. Once we have that, we are able to find the function that represents the area. Once we found the function that represents our area, we are able to find the x value of the vertex, which is what we did right here.